Hello everyone. Okay, so I just want to send a quick reminder video that tomorrow we're doing the IMF Unit 7 test that we did the review last class. And I wanted to highlight one type of question, go over that with you guys in the video. And so if you have gone through this review and you're feeling really confident on the review, you'll do great on the test. We spent time in class last time going over the review. And then I have the answer key as well. And so at the end of the video, I'll go through that page by page in case you need to go back and look at any of it. Okay, so the question on the test that students tend to struggle the most is with question 3, this type of question. And it has a lot to do with wording. So number 1 says, what is holding atoms together in CH4? And we have what is holding ammonia molecules together, and then we have what is holding ions together. Okay, so we're either saying, hey, what's holding atoms together, what's holding molecules together, or what's holding ions together. So if we're holding atoms together inside a molecule, then you have one of two answer options. It's either going to be polar covalent bonds, or it's going to be non-polar covalent bonds. So if it says, hey, what's holding the atoms together, your answer should either be A or B. And this is how I would figure that out. I would draw this Lewis dot structure, so like CH4. And the question is not, is this whole molecule polar or non-polar? It's saying, what is holding the atoms together? What is this bond that's holding the atoms together? Is that a polar covalent bond or a non-polar covalent bond? And on the test, I'm going to give you guys an electronegativity table. And this bond is between carbon and hydrogen. And so carbon is 2.55 on the electronegativity table, and hydrogen is 2.20. So I always take the bigger one minus the smaller one, and then I would subtract those, and that has an electronegativity difference of 0.35. And on the board I have it written that if it's between 0 and 0.4, that it's non-polar covalent bond. And so that's what I would put for this one, B, non-polar covalent. Okay. Here's another example where it says what's holding the atoms together, and it's an HF. So then I'm going to draw that Lewis dot structure. So this is the bond that I'm talking about, and this bond is between hydrogen and fluorine. And so again, I'm going to come right here and I'm going to look at fluorine and I'm going to look at hydrogen. Now I like this example because this is two non-metals, right? Everything to the left is metals, everything to the right is non-metals, except hydrogen, even though it's to the left, is a non-metal. So we got fluorine and we got hydrogen. So whenever it's non-metals that are bonded, it's got to be covalent, and it's either going to be polar covalent or non-polar covalent. And if I subtract these, 3.98, what was it showing? There we go, 3.98 minus 2.2, I get 1.78. Now technically, and there it really is kind of fuzzy, the cutoff is 1.7 into ionic, but we know this can't be ionic because it's two nonmetals, and so anything above 0.4 I would categorize as a polar covalent bond. So this one down here is a polar covalent. Okay, now let's talk about molecules. What holds two ammonium molecules together? Now, I'm not saying what holds the atoms together, I'm saying what holds the molecules together. So if I were to draw a Lewis dot structure of this NH3 molecule, there's one of them, but there's other ones around it. other molecules of NH3. And the question is not what's holding the atoms together, it's what's holding the molecules together. So here's the molecule, and what's holding them together. Now these are your answer options. Your answer could either be London dispersion, or it could be London dispersion and dipole-dipole, or it could be London dispersion, dipole-dipole, and hydrogen bonding. And so we got to decide. So first off, any two molecules, anytime it says what's holding molecules together, automatically London dispersion is going to be one of your answers. Okay? If both of the molecules are polar, like here we see the asymmetry with that lone pair, then it's also dipole-dipole. And then if we meet the criteria for hydrogen bonding, where one molecule has a lone pair and the other molecule has a hydrogen that's bonded to fluorine, oxygen, or nitrogen, then we also have hydrogen bonding. Let's try this again. Number 5 also says what is holding two molecules together. And so we know what our potential answer options are. And this time it's a hydrocarbon. It's a molecule that contains only hydrogen and carbon. So we could draw the Lewis dot structure, but we don't need to because hydrocarbons are always nonpolar. So if I have a C2H6 molecule, there is an IMF attraction to any other C2H6 molecule. And so if I have two molecules, there will definitely be London dispersion. But they're not polar, they're both nonpolar, so it can't be dipole-dipole, and if it can't be dipole-dipole, then it can't be hydrogen bonding. And that's the same thing that happens here. What holds two I2 molecules together? And we see a diatomic molecule. Any molecule that is just two of the same atom is always nonpolar. And so same deal, if it's an I2, and there's an IMF to another I2, then the only option we have is London dispersion. Okay, last one. What holds ions together? Ionic bonds. Like as soon as I say an ion, your only answer option is an ionic bond. The other way to catch this is that it's a metal and a non-metal. When you have a metal and a non-metal together, then that's an ionic bond. Okay. So I would say that question is like the most difficult for students. So I wanted to talk through that and then just make sure you spend a little time reviewing this review. Here I'm going to slowly go through the pages so you can see answers in case you missed any of them. But there's number 1 and number 2. Pause the video or rewind if you need to. We just went over number 3. Here's 4 and 5. And then number 6. And number 7. And I know I'm writing in cursive, so I'll just read the answer to this last one. CH4 only experiences London dispersion, where H2O has London dispersion, dipole-dipole, and hydrogen bonding. The stronger IMFs of H2O make it a liquid, where the weaker IMFs of CH4 make it a gas. All right, everyone. Please come prepared. We're going to take the quiz right at the beginning of class because the second half of class, I actually want to do the silver and gold lab. Our Friday got cut down just a little bit with the gold rush assembly, like the what are they calling it? Wish box assembly. And so I'm worried that we're not going to have time for the silver and gold lab, so I want to do it tomorrow instead. And then on Friday, we'll quickly grade our quizzes, and then we'll do a really fun, like, slime making lab. So I'm looking forward to seeing you all tomorrow, and then on Friday, and it'll be fun. Get some good chemistry done. All right, thank you all. Bye.